Hi everyone. Sorry I'm not here today, but we will move on. Okay, we're going to talk about section 7.4 arc length more specifically today. After Thanksgiving, we'll come back talk surface area. So we'll hold off on the proof of the arc length formula until tomorrow, but let's just kind of get some of the basics down right now. All right. So first of all, what is arc length? Well, arc length, if you remember from geometry, is just the distance around a curve. Okay, so if we're looking at this curve here, we're looking at that distance. Okay, how far did we travel? Okay, so the arc length is simply approximated by straight line segments whose lengths are given by the distance formula. Now, this arc length formula, since we're going to be adding up all of these distances, is a little special case of this distance formula. And like I said, we will go through the derivation of this formula tomorrow. Okay, so there are some conditions, however, in order to find an arc length of some curve. Okay, the first thing is f prime needs to be continuous on this curve. Okay, f prime needs to be continuous on this curve. On that interval, okay, which then means f is continuously differentiable. On that same interval. Okay, so essentially what we're doing to find this arc length is if we are looking from A to B, okay, you can kind of see these approximations. Well, if that's our x1 and this is our x2, we can find the distance between these guys, okay, and add up all these distances. All right, so if we're kind of generalizing this, if we let this be xi, and then this be, or you know what, let's let that be xi minus 1, and then this guy be xi. What we're essentially doing is we're finding the distance of these intervals, okay? So we know the distance formula. It would be xi minus 1 squared plus yi minus 1 squared. That's square root, okay? So what this turns into, since we're finding the sum of all of these distances, is we are essentially finding the integral. Okay, so arc length is equal to the following. So we call arc length S. Okay, and if we're looking on the curve from A to B, S is equal to the integral from A to B of the square root of 1 plus f prime of x, and we're going to square that dx. Okay, or if we're using our y's, we could go ahead and say that s is equal to the integral from C to D of the square root of 1 plus f prime of y squared dy. Okay, so those are the key, and I will show you where those came from tomorrow. Okay, mean value theorem certainly has something to do with it, so we'll come back to that. Okay, so now we're going to get into this first example. Let's find the arc length, or the length of the arc, on f of x between the point 8, 2 and 27, 17. For the graph, f of x equals 3x to the 2/3 minus 10. Okay, so the first thing we need to do is find the derivative. So let's find f prime. All right, so f prime is going to equal 2x to the negative 1/3. And at the same time, we can find f prime squared, because we'll need that in the arc length formula. So when we square that, we'll get 4x to the negative 2/3, which is the same as saying 4 over x to the 2/3. Okay, so now we can go ahead, excuse me, and plug this into our arc length formula. Okay, so leave some room, all right, because these can get kind of tedious. So our arc length is going to be equal to the integral. Now we're looking at the x values here, so we're going from 8 to 27 of the square root of 1 plus our derivative squared, which we found was 4 over x to the 2/3 dx. Okay, so when we combine these, this is going to clean up to the integral from 8 to 27 of the square root of x to the 2/3 plus 4 all over x to the 2/3 dx. Well, we can take the square root of that denominator. The square root of x to the 2/3 is x to the 1/3. And if we bring that up to the numerator, we're really looking at the integral from 8 to 27 of the square root of x to the 2/3 plus 4 times x to the negative 1/3 dx. So if we do a u substitution, if we let u be x to the 2/3 plus 4, then du is going to equal 2/3 x to the negative 1/3 dx. And so that's going to put us over here. And now our surface area is equal to the integral. Actually, sorry, let's take that back. It's going to be 3/2 times the integral from 8 to 27 of essentially u to the 1/2 du. Okay, so we're looking at 3/2 times 2/3 u to the 3/2 on that interval, but we do need to substitute back in. So now we are looking at, well, the 3/2 and 2/3 cancel, and we're looking at x to the 2/3 plus 4 raised to the 3/2 on the interval 8 to 27. And what we will get, essentially 9 plus 4 to the 3/2 minus 4 plus 4 to the 3/2. And final answer, 13 to the 3/2 minus 8 to the 3/2. All right. So these are just tedious, right? You just have to be careful. So take your time and show your steps. Okay, let's try this last example. Again, we just have to be very careful and show all of our steps, okay? So we want to find the length of the arc on f of x between x equals 2 and x equals 5 for y is equal to x to the 5th over 10 plus 1 over 6x cubed. Okay, so instead of y, we can call that f of x. All right, so first thing we've got to do is find the derivative. So if we do that, we've got f prime of x is equal to, we're going to have 1/2 x to the 4th minus 1/2 x to the negative 4th. If you rewrite that 6x cubed as 1/6 x to the negative 3, okay? So when we kind of clean this up, it looks something like this. X to the 8th minus 1 over 2x to the 4th. Okay, so there's the cleaned up version of f prime. We can go ahead if we want to square this. So f prime squared is simply going to be, I can square that numerator. When we square the numerator, we're going to get x to the 16th minus 2x to the 8th plus 1 over 4x to the 8th. Okay, so now we're ready to go ahead and find the arc length. All right, so arc length S is equal to the integral from x equals 2 to 5 of 1 plus x to the 16th minus 2x to the 8th plus 1 over 4x to the 8th dx. All right, getting common denominators, we will have the integral from 2 to 5 of the square root of 4x to the 8th plus that quantity x to the 16th minus 2x to the 8th plus 1, and now it's all over 4x to the 8th. That is still underneath the radical. Okay. And if we clean that up even further, we are looking at the integral from 2 to 5. Combining those like terms, we will have x to the 16th plus 2x to the 8th plus 1 over 4x to the 8th dx. And that numerator factors nicely. So it's the integral from 2 to 5 of the square root of x to the 8th plus 1 squared over 2x to the 4th squared dx. Okay, so since those are both perfect squares, we can take the square root, and now we have the integral from 2 to 5 of x to the 8th plus 1 over 2x to the 4th dx. Okay, and now we can split it up into our two fractions, x to the 8th over 2x to the 4th plus 1 over 2x to the 4th. So by splitting it up, it'll look like the following. The integral from 2 to 5 of 1/2 x to the fourth plus 1/2 x to the negative fourth dx. And when we take the antiderivative of this, we'll change it up. We will get 1/2 times 1/5 x to the fifth plus 1/2 times negative 1/3 x to the negative 3. And we're going to take this from 2 to 5. And I'm going to have to move up over here. Okay, which comes out to be 625 over 2 minus 1 over 750 minus 16 over 5 minus 1 over 48. And when all is said and done, we end up with 618,000. 618,639 over 2,000, or 309.3195. All right. Okay, so your homework tonight is day 66. We'll go over the derivation tomorrow. We'll go over the multiple choice tomorrow as well and kind of clean things up before Thanksgiving. See you tomorrow. Bye.